So next we have TCP, UDP, and router components. Now TCP and UDP, which layer protocols? Layer 4. What is the layer 4? Transport layer. Okay. Now at the transport layer, we have discussed yesterday that, okay, what are the different tasks of transport layer, like segmentation, flow control, error control. Okay, these kind of tasks we have seen. So all these tasks belong to these two protocols only, TCP and UDP. And one more important point I gave you, that TCP and UDP, they provide service to the application layer protocols. Okay. Now see how they provide, because they make use of the port numbers. And based on the port numbers only, your applications are able to deliver the data to correct applications. Okay. And one more thing can be asked, that what is the size of port numbers? So the size of port number is 16-bit. Because yesterday I said, right, total how many ports are there? 65,536. So 2 raised to power 16 is only 65,536. So this is the size of your port numbers, 16-bit. Okay. And total port numbers 0 to 65,536. Range will start from 0 to 65,535. Out of all these ports, 0 to 1023, well-known ports. Reserved ports, well-known ports. Then after 1024 till 65,535. These are your dynamic ports. These are your dynamic ports. Okay. This is clear? Okay. Now we'll see about TCP and UDP. So your TCP stands for Transmission Control Protocol. Okay, these are the two protocols that is used at the transport layer. TCP stands for Transmission Control Protocol. Now your Transmission Control Protocol is used on the top of IP to ensure reliable transmission. Now we say your TCP is what? Reliable protocol. And your UDP is what? Unreliable protocol. Okay. Now, why do we say your TCP is a reliable protocol? Because your TCP includes mechanism to solve many problems that arise from the packet-based messaging. Now, what can be the problems during the transmission of the packets? We can have lost packets, we can have out-of-order packets, duplicate packets, or corrupted packets. These kind of scenarios can be there. Okay. How do your TCP avoid lost packets? Remember yesterday? Error detection, error control, right? Error detection and error control. Detects the error, whether all the packets have been received or not. Okay. Then also have checksum to detect corrupted data packets, correct? So can avoid corrupted packets as well as lost packets. Then about out of order packets, remember what your transport layer does? Sequence number, so that the receiver can rearrange the data in the correct sequence. Okay. Duplicate packets. This you will understand when we understand the flow of TCP, how the TCP is making the flow. Okay. What happens? See, basically, let me tell you what happens. Let's say this side we have a sender, this side we have a receiver. Okay. One is sender, one is receiver. So when sender will send something, so we'll send with the sequence number. Let's say it has sent sequence number 1. Okay. So what the receiver will say? Okay, I have received. Acknowledgement. Sequence number 2. Acknowledged, received. So there is an acknowledgement in case of TCP. So is there any chance of duplicate packets? Because your sender will not send the same packet again until or unless the receiver is requesting for it. Okay. The sender will not send that packet again until or unless your receiver is requesting for it. So there is no chance of duplicate packet. Why? Because we have the acknowledgement. Okay. Then the protocol number of your TCP is 6, like your ICMP is 1. Okay. So for TCP, protocol number is 6. For your UDP, the protocol number is 17. Okay. For these two protocols, you must have to remember the protocol numbers. Okay. Like TCP 6, UDP 17, ICMP 1. Okay. Noted?
Hello, Ajay.
Yes, please tell me.
I lost you in between actually.
Yes.
I can't able to hear you. No, only I can able to hear you.
You're not able to hear my voice.
Now it is clear. Now it is clear.
Okay. Okay, noted. See, these slides also I'll share. So no need to note down everything. Okay. This presentation and everything I'll be sharing in the drive. Okay. Then UDP. What is UDP? User Datagram Protocol. So in case of TCP, we call it as a segment. In case of UDP, we call it as a datagram. Okay. Now UDP is a lightweight data transport protocol and the protocol number is 17. Okay. Why it is lightweight? Because it does not have so many features like your TCP. Okay. And these features you will understand when we compare the header of your TCP and header of your UDP. What is a header? Yes, means header is something that we attach in front of the information. Whatever information is there in front of that, if we attach some extra information, that is that part where we attach the information is known as header. Okay. So for TCP and UDP, we'll see the headers, and when you compare the headers, you'll see that UDP is not having anything in comparison to TCP. Okay. So UDP provides mechanism to detect corrupted data packets. Now, just to detect means UDP also has something called as checksum, but it does not attempt to solve other problems that arise with the packets, such as lost packets. In case of UDP, you cannot regain the lost packets. In case of UDP, you cannot reorder the packets, means there is no sequence number mechanism, there is no acknowledgement mechanism, there is nothing like that. Okay, that's why UDP sometimes known as unreliable data protocol. Why? Because UDP, there is no acknowledgement, where we get no confirmation that the data is getting transmitted or not. Okay, out of order packets means there is no guarantee that you will get correct delivery. Whenever you were watching something live, there are chances that you might get the video first and audio is coming later. Like means imbalance can be there. No synchronization can be there. There is a possibility. Or sometimes due to bad weather or something, what happens? You see like glitches. Why? Because something is coming before, something is coming after. So like this, you see the glitches also. So in UDP, this is no guarantee that you will get it data in the correct sequence. Okay. UDP is simple but fast. Why fast? Because UDP, first of all, there is no process of acknowledgement, so it will not wait for the acknowledgements. Second thing, it is not going to reorder, it is just going to keep on sending. That's it. Okay. So UDP is simple but fast, and it is often used for time sensitive application. Now, what does it mean with the time sensitive? Where speed is more important than accuracy. That is time sensitive. Okay, we do not care about the accuracy of the data, we just care about the speed. Okay, so we can say comparatively your UDP is faster than TCP. Compared to TCP, UDP is faster. Okay, and where UDP is used, such as real-time video streaming. So all the live streams and everything, that will be your UDP based, where speed is more important than accuracy. Okay, now we'll see why your TCP is reliable and why your UDP is unreliable. We'll see the packet flow. Okay, so in case of TCP, what happens? Let's say this is one client, this is one server. They want to transmit or exchange some data. Now, how this thing will happen? Before transmitting any data, your TCP will always establish a connection between the sender and receiver. Okay, and how they are going to communicate? So they are going to exchange 3 packets. One is the SYN, second is the SYN plus ACK, and third is the ACK. Okay. Now, what is the SYN, SYN-ACK, and acknowledgement packets? SYN packet, it is known as the synchronizing packet. Okay. And what they are trying to synchronize? Sequence numbers. The sender and receiver, they are going to agree on a sequence number. Like sender will, the client will say that for communication, I will use the sequence number 0, means I'll start using the sequence number from 0. So the server will say, okay, now I know that you are going to use the sequence number starting from 0. That means when I will be reordering the packets, I will start assembling from 0. Then server will also say that whenever I'm sending the data, maybe I'll also use sequence number 0. Now the client also knows that from where it has to start assembling the data. Okay. And then they are going to provide confirmation. So see here, it is sending SYN packet, means synchronizing packet, giving the information to the server that, okay, I will use this sequence number. So server, first of all, it will acknowledge that, okay, you can use this, but also at the same time, it is going to send its synchronization or sequence number. It is going to send its own sequence number, and then the client is going to acknowledge this request that, okay, now both client and server, they know that, okay, what are the sequence number they are going to use, means they have agreed on the same sequence number. Now they can start exchanging the information. Okay. So this is how it is done. Okay. Kind of, you can say the client is going to ask the server, okay, are you free? I want to share some data. I want to exchange some data. Okay. Server will say, okay, I'm free. Let's start exchanging. And he will say, okay, now agreed. Now let's move on to exchanging the data. Okay. Now, how this sequence number and acknowledgement number works? See, in the SYN packet, let's say it is saying, now once they have synchronized, they know that, okay, they are going to use these sequence numbers. So what will happen after this? When they start actually exchanging the data, so SYN, SYN-ACK, and ACK, after this, there will be a state. This state is known as connection established state. Connection established means they both know that, okay, we have agreed. So now the connection between us is established. Once the connection is established, again, let's say this side, it is the client, it is the server. Okay. Now let's say client is requesting some data. So client is sending the first packet this side. So in this request, it will say sequence number 0, because it will use sequence number 0. So given sequence number 0, what will happen? Server will acknowledge this. How server will acknowledge this? So whenever server will acknowledge, what will happen? It will send always, it will add +1 in the synchronizing. Whatever is the sequence number, always going to add +1. This +1 is known as the ghost bit that they are always going to add. Okay. Or let's consider this is a client, server. Okay. Consider it like this. Server, client. So when server is sending some data, use the sequence number 0. Now client will say, okay, I have received. So how it will say? By adding +1. So when it is sending the acknowledgement, what will be the acknowledgement number? Sequence number +1. Okay. So this will be 1. Now, if the server is receiving sequence number 1, server will come to know that, okay, the client is willing to receive the next sequence number, that is 1. So server will send the next sequence number, that is 1. Now this time again in the acknowledgement, client will add +1, that will be 2. So by looking at the number in the acknowledgement, server will come to know that which segment your client is willing to receive. Okay. Willing to receive number 2. Let's say this time server has sent sequence number 2. Okay. Due to some reason, lost in the communication. Then what will be the sequence number according to the server? Next sequence number? 3. Okay. And this has been received. Now, according to this, when client will generate the acknowledgement number, what will be the acknowledgement number according to this? According to this, 4. But it will check that, okay, I have sent 1, I have sent 2, I have not sent 3. Means this thing is missing. If this thing is missing, your client will again say sequence number, acknowledgement. Client will give the acknowledgement. Okay. It will say acknowledgement number means instead of giving acknowledgement number 4, it will give the missing acknowledgement number. Now, what your server will come to know that it is willing to receive. Okay. We consider this as a delivered mistake. Understand? Not the third missing acknowledgement number 2, because sequence number 2 not received. So again, it will send acknowledgement number 2. Now what will happen? Client will send what? Sequence number 2. Now once it receives, it is going to give acknowledgement for number 3, as well as this also received. So it will give one acknowledgement for acknowledgement number 4. Both received. Now server will check, okay, the largest acknowledgement number is 4. That means next sequence number should be 4. Like this, they will transfer the information. Okay, check again. Okay, I think you're confused. Sequence number 0, acknowledgement will be +1. Acknowledgement equals to 1. That means sequence number 1, acknowledgement number 2. Sequence number 2, lost. Sequence number 3, received. Okay. Now, before generating this acknowledgement number 3, what it will do? I mean, before generating the acknowledgement number 4, what it is going to do? It will check acknowledgement number 2 sent. Okay. But sequence number 2 not received. So what it will do? Generate acknowledgement number 2, because I sent the acknowledgement, but I haven't received the sequence number 2. So again, acknowledgement number 2. Then server will see, means next packet willing to receive is, see, server will send the packets according to this number only. Okay. So it will send again sequence 2, now received. So acknowledgement number should be 3, but also received sequence number 3. So acknowledgement number 4. Now what is the maximum acknowledgement number? 4. Means next. Sequence. Here it will send the sequence number 4. And next, keep on going like that. So this is based on the acknowledgement number. They are going to detect whether missing data packet is there or not. This is how they are going to transmit the information. Is that clear? Okay. Now see. So first of all, they are going to synchronize. Now for synchronizing, how many packets they are exchanging? 3 packets. So this is known as three-way handshake. TCP, three-way handshake. So TCP three-way handshake. Why it is used? To establish a connection. Okay. Then after the establishment of connection only, the actual data transfer will start. If this TCP three-way handshake is not complete, data transfer will not start. Is that clear? Okay. Means this is kind of thing, let's say, for example, you want to watch a movie with your friend. Okay. There is you. There is your friend in some other location or at his home, and you are at your home. Now you want to watch a movie. There are 2 approaches. One, first you book the ticket for both of you. Then you ask your friend whether he is available or not. Second approach, you first confirm with your friend that, okay, whether he wants to go or not. And then you book the tickets. Okay. First case, when you already booked the ticket, what will happen? If you already booked the ticket, okay, and then you call your friend that, okay, let's go and watch a movie. And if your friend says, no, I'm not busy. I'm busy. I cannot go. What will happen? UDP approach. Understood? No confirmation. No confirmation, direct booking, direct sending the information. Okay. Means you're directly giving the information that, okay, let's go to watch a movie. I have already booked the tickets. Now, if he is not free, there is the means the ticket is waste. Similarly, the data is going to drop. No guarantee. Second thing, you will call your friend. You will ask, first packet, are you free? Friend will say, okay, I'm free. What's the deal? You'll say, let's go to watch a movie. And he'll say, okay, let's go. And then you'll say, okay. Then we are meeting on this date, that and the place and everything. Means, first of all, connection established, and then you will book the tickets. Then you will transfer the information. Okay. So this is how it is done. Okay. So this is your TCP three-way handshake where sequence numbers are synchronized. Both sender and receiver, they agree on the same sequence number that, okay, they are going to use this particular sequence number for the data communication. Okay. All right. So once the connection is established, actual data transfer starts. Now, let's say your data transfer is completed. Okay. Now your data transfer is completed. Now, in case of TCP, for terminating the connection also, we have one more handshake that is known as the four-way handshake. Okay. For session termination. Once, let's say again, this is your client. This is your server. Once client has received all the data, client will say, okay, I have received all the data. Server will say, okay. So I'm terminating the connection. Then server will say, okay, I'm also done sending all the information. Client will say, okay. So we can terminate the connection. So both will agree that, okay, from both sides, the communication is done. Now we can finish the session or we can break the connection. Okay. So for terminating the session also, we have a handshake. Okay. And that is known as your four-way handshake. So three-way handshake is for establishing a connection. Four-way handshake is for terminating a connection. Now in the four-way handshake, we have a fin bit. Fin means finish bit. Okay, these bits are there, these flags are there in your TCP header. There we will understand. Okay, so they will they will do whenever they are sending the information, when they're sending the data, in that data they will turn this bit to on. See, only binary two values, 0 means off, 1 means on. So here they will turn this bit to on, and then one will acknowledge. Then he will also send the finish bit on, and he will acknowledge, and they will terminate the session. Is that clear? Three-way handshake for establishing the session. Four-way handshake for terminating the connection. Okay. This is TCP packet flow. Now, if you see UDP packet flow, this is one simple UDP packet flow. Okay. Sender, receiver. Receiver will request for some information. Now, sender will just start sending the information, flooding the receiver with the information. Doesn't matter whether he is receiving or not receiving. Kind of thing. You are angry on someone, you just call them. Okay. Doesn't matter whether your friend is listening, whether his parents are listening, you just start speaking everything. No matter what they are, who is the person next to them, whether they are listening or not listening, doesn't matter. So you just keep flooding the information and then you cut the call. That's it. No confirmation. Okay. So this is the approach. When receiver will request for some information and the sender will just flood the receiver with the information, doesn't matter what. Let's say for the example, you can take your FM radio station. Do they care who is listening, who is not listening? The news channels, do they care who is listening, who is not listening? Whether everyone is receiving, or do we give any confirmation that, okay, we have received your channel, we have seen your news and these things? No. Why? Because that's all the UDP. Okay. Similarly, when we are going through the class, now what will happen? This class, no one is going to give me confirmation that, okay, whether they are able to see or not able to see. Why? See, right now the persons who are sitting, we have two-way communication, but that is the simplest type of communication. Okay. So here what will happen? The people will say me, but again, I cannot do anything from here. Why? Because if they have the internet connection issue on their side, so I cannot fix that thing. From my side, data is just going. I'm not getting any confirmation. That thing you can see here also, because we have UDP approach. So if I show you the Wireshark packet capture, so you will see the information just going from my system. You will not see anything like acknowledgement. See, this is my Wi-Fi. Now you see, the information is just going over the UDP. There is nothing such as acknowledgement. And if some TCP packets are going, see, for some TCP packets, we have something called as acknowledgement. But in case of UDP, do you see anything like acknowledgement? Always in the TCP, you will see acknowledgement, but in UDP, you will not see acknowledgements. Okay. Then the second thing, if you want to see the three-way handshake. So see, let's say if when you visit a website, what happens? When you visit a website, what will happen? TCP, STTP or HTTPS, port number 80 or 443. So before you interact with the website, always a TCP session will be established. Okay. So for example, let me show you one sample packet capture. Okay, so sample packet capture. Now these things are not related to your CCNA, but still for information that will be good. Let's say for HTTP, I will see. Let's say this HTTP packet capture, I will show you this. If I open this, it will open in the Wireshark, and there we can see. See, this is one sample. So they are trying to visit a website here. If you see the first packet, what is the first packet? Is it visible? Okay, let me do one thing. Magnify. See here. What is the first packet? What is the second packet? What is the third packet? Okay. See here. What is the sequence number? For sequence number, and then what is the acknowledgement number here? Now here it also gave at the same time sequence number. Correct? And then what happened? Next acknowledgement number by the client 1 and given the sequence number 1. So like this, they will keep on increasing the sequence and acknowledgement. When one side gave, let's say this is my PC and I'm interacting to a website. So my PC said, I will use sequence number 0. Website said, okay. And website said, I will also use sequence number 0. My system is saying, okay. And already, because this is acknowledgement number 1, so my next segment will already have sequence number 1. Is that clear? So this is how they confirm. And after that, all the entire communication is going to happen. Is that clear? So this is how the things work. So always first TCP three-way handshake will happen, and then only you will get the actual data transfer will start. Okay. So TCP UDP packet flow clear? Differences between TCP and UDP. So if we go with the differences, first of all, connection oriented, connection less. State memory, stateless. This is going to maintain the connection, check for the connection all the time. If anytime connection broke, the TCP three-way handshake failed, data communication stopped. This is stateless, not maintaining state of connection. Here we call it a not byte stream, you call segment. You call it as a segment. And here we call it as a datagram. Then ordered data delivery. Why? Because we have sequence number. Is there any sequence guarantee in UDP? No. Why? No sequence number. TCP is reliable. Lossy means there are losses. TCP is error free. Here we can check for the errors and discard the packet, but we cannot ask for retransmission. So if we cannot ask for retransmission, the error is still not removed. Okay. Here we have three-way handshake, four-way handshake. Here, no handshake. Here we have flow control. There is no flow control. TCP obviously relatively slow. Why? Because acknowledgements and three-way handshake, four-way handshake, lots of processes are there. Here it is relatively fast because none of these processes are there. Okay. So in most point-to-point communications, your TCP is used, and in most multicast and everything, your UDP is used. Is that clear? Okay. Now we'll see the headers for TCP and UDP. So this is how your TCP header looks like. Okay. So the size of your TCP header ranges from 20 bytes to 60 bytes. Okay, the size. See, these are the information. First is source port. Now, what port number defines about the application? Source application. Can I say source application and destination application? Okay. So source port means from which application the data has come. So this will be a source port and there will be a destination port. And what is the size of this thing? 16 bit. Okay, so they will range from 0 to 65,535. Okay, and if you see right now, the capture we saw here, okay, the capture we saw, that was HTTP capture. So port number for HTTP is 80, correct? Let me show you. This is HTTP packet. If I see this packet, see here, source port will be randomly assigned by your PC and destination port is 80. Why? Because I'm communicating with the destination protocol, that is HTTP. Okay, so that's why I have the destination port number 80. Is that clear? So source port, destination port. Then we have sequence number. Why sequence number is used? For correct delivery, for correct reordering of packets, right? What is the size from here till full? 16 plus 16. What is the size here? 32 bits. So your sequence number size is 32 bit. This is 16 bit. This is again 16 bit. Okay. Acknowledgement number also 32 bit, used for acknowledgement, and sequence number used for segment sequence number. Then we have header length. What is the header length? Header length is whenever the receiver will receive the segment. Okay, now the receiver has to know that what is the actual size of the header. Okay, and then from where my actual data is going to start. So there has to be some information that is going to tell the receiver that, okay, this much is header and remaining is data. So this header length is going to define the header of your size of your TCP header. Then we have reserved bits. These reserved bits nowhere used, never used, all set to 0 forever. These are all set to 0 forever. These are always 0, never used. Okay. Then these are known as the TCP flags. Total 6. These are the known as TCP flags. 6 flags are there. First is URG. Means, what do you think? What does it mean? Urgent. This is the urgent flag. Urgent flag means sometimes there is some information that has to be given special attention. Okay. So this URG flag will be on. So if a receiver receives a segment with this bit set to 1, urgent bit set to 1, that means special attention will be given to the packet. Okay. Then next is ACK. What does it mean? Acknowledgement. And when do we give the acknowledgement? Whenever there will be acknowledgement number, this bit will be set to 1. Okay, you can see these flags also I can show you. This is what acknowledgement. Okay, see here in the TCP, there are the flags. In the flags, do you see this? Which flag it is? Acknowledgement. Is it set to 0 or 1? 1. Why? Because this packet is acknowledgement packet. Okay, so like this, the information they get. See, do not need to confuse with all these things. Okay, these things will be repeated again in your CCNP and everything. Push bit, PSH, push, right? So your push bit, whenever a receiver receives a segment with the push bit set to 1. So what does it mean? See, we know the sender is going to send the data, the receiver is going to receive the data. But before delivering this data to the correct application, receiver is going to assemble the data, correct? Assemble the data and then order it in reorder it in correct sequence, then it is going to send. So means before delivering, it is going to store it somewhere for some time so that, okay, it can receive all the segments and then reassemble it, correct? So that memory is known as the buffer, where it stores the packet before delivering the information. Now in the buffer, let's say there are some packets already. So it is going to wait for this buffer to fill, then going to rearrange it and then going to send it. Okay. Now what will happen? If the receiver receives a segment with the push bit set to 1, it will not wait for this buffer to fill. It will instantly deliver the data to the application. Not going to wait for the buffer. Usually waits for the buffer to fill, then it is going to send. But if the push bit is on, instantly empty the buffer. Send all the data to the application. Then sometimes what you see, what happens, that whenever you are receiving something, first time you do not get it properly, then you refresh it, then it comes proper. Let's say you are loading a web page. So first time it will not look clear sometimes. Okay, not always these things happen. Sometimes. So you will not get it properly. And then when you refresh it or reload it, you get all the segments, and that time you get it proper. Okay. Reset. What does it mean with the reset? Reset means, like, if you want to reset whatever is the configuration, just remove it and then restart. Similar way, if a receiver receives a segment with the reset, what will happen? It will instantly terminate the connection and reestablish the TCP three-way handshake and everything. Instantly terminate the TCP connection and reestablish. SYN, where it is used? Three-way handshake. We just saw, right? In the three-way handshake, the first segment is what? SYN. And FIN, connection termination, four-way handshake. Okay. So these two now you already know. Flags are clear. Next, we have window size. What is this window size? So remember flow control. In case of TCP, we have flow control where we can adjust the speed of communication, increase or decrease. So we do not do that manually. We do not decide. Your receiver decides that. How? Sender, receiver. Sender and receiver. Now what will happen? They are exchanging the data. Let's say, for example, sending sequence number 1, sending acknowledgement number 2. So whenever the receiver is sending acknowledgement number, it is also sending the window size. Now, what is this window size? Let's say it is saying window size 100. So window size is basically the amount of data your receiver is willing to receive without any drop. It's window size is the amount of data your receiver is willing to receive without any drop. Okay. So what will happen? Sending, let's say, acknowledgement number 2 and sending the window size 100. Now what will happen? The sender will only send 100 bytes of information. Okay. It will send sequence number 2. But with the sequence number 2, the size of data will be 100 bytes only. Okay. After that, let's say the buffer has been empty. More space is available in the buffer. So when the next acknowledgement is given, let's say acknowledgement number 3. So it will say, let's say now I can receive more. For example, let's say 1000 bytes I can receive. So the receiver is always with each and every segment, it is advertising that, okay, how much data I'm willing to receive. And according to that only, the sender is sending the information. Okay. Let's try to see this thing also. Let's say this is an acknowledgement. Do you see? Window size everywhere in the acknowledgements. So like this, the receiver is going to always advertise the window size, and the sender is going to send only that much of information. Okay. Then we have checksum. I don't think I need to explain this thing now. Checksum for error detection. Urgent pointer. What is urgent pointer? Remember urgent bit? When this bit is set to 1, that means the data has to be given, the segment has to be given special attention, right? Now, how much data of the segment is to be given special attention? That will be defined here, because this is just binary, 1 or 0. This can tell that, okay, this segment needs special attention or not. This has to be forwarded immediately or not. But how much data out of that segment is important? That will be defined by your. Okay. Then after, we have options. There are certain options like you can configure source route. Okay. So if there are special options attached with the packet, then it will take up this space also. Otherwise, usually this will be 0. The options will be set to 0. So that's why if you do not set any option, see, option range from 0 to 40 bytes. So if you do not set any options, your TCP header size is 20 bytes. And if you set 40 bytes, let's say all the options you set 40 bytes of options, then it will become 60 bytes. And after that, you will have your data. So you see in TCP, what all the information we have, large information we have. Okay. TCP header is clear. Any doubt? Okay. Now let me show you UDP header. Yes.
Fill options, it is only headers.
Hmm?
Fill options.
Header size, yeah.
Data. It is only header size.
Header size.
20 plus 40, 60.
Yeah, before the data, 20 plus 40. If the options are set. If the options are not set, 20 bytes. Data size is different. Okay. This is just the header size. Okay.
Total 60 bytes is the header size.
60, yes.
Maximum.
Yeah, maximum. 20 to 60 bytes maximum. Okay. Minimum 20, maximum 60. Okay. Now compare this header with the UDP header. What all the information you have here? Source port, destination port, length, and checksum. So what you do not understand out of this? Which part I need to explain? Header length. Length is header length. Checksum, error detection. Source port, from which application the data is coming. Destination port, to which application data is going. Is there anything related to the flags? How to give spatial attention? How to reset the connection? Nothing. Is there any sequence number? No. Is there any acknowledgement? No. Is there any window size? No. So means whatever we have studied in case of the transport layer, the segmentation, the flow control, the error control, everything, all those features were for TCP, not for UDP. Okay. And in case of UDP, let's say again, if you take that example of the flow control, let's say this can send at 100 MB per second and this can receive only 10 MB per second. If they are using TCP approach, they can do the flow control because it will advertise window size every time. But if they are using UDP, now doesn't matter. This will just keep on sending. Doesn't matter whether the receiver is receiving or not. Okay. This is clear about TCP and UDP. Then next we'll discuss. Yes.
Yeah, actually, in case, right, for your case, let's consider the UDP scenario. Like, let us consider the transmitter, like the sender is sending with 10 Mbps, but the receiver can be able to receive only 5 Mbps. So, what will happen in this scenario actually?
The data will drop. Incomplete information will be received.
Okay, then real time, how they will manage actually?
See, real time. See, in case of real time, let's say you are watching news. Okay, so on your side you have weather issues. Correct.
Okay.
Now you're not receiving the news properly. So does it affect the sender, the news channels?
No.
Right. So it doesn't matter to the sender that whether the receiver is receiving or not. There is no such acknowledgement process, nothing. Always the data will drop, that's it. Like in calls also, normally your calls you do, they are real time. Okay. So if due to network, due to some network issue on your side or the sender side, if some part of the voice is left, missed in the transmission, do you get that? No, you have to ask again that, okay, what did you say? Then he is delivering again. So right now we are having two-way communication, plus we are humans. But again, the calling process, that is UDP only. The calling process is not going to give you the data. You will get always incomplete data in case of UDP transmission. Always in the sense means if there is due to any issue, the data is lost. That same data you will not get again. Okay.
Okay, fine.
All right. So any doubt with the TCP or UDP? Clear? UDP protocol number 70. TCP protocol number 6. TCP is reliable. UDP is unreliable. Okay.
UDP header size.
Header size. This is all the header size. 2, 4, 6, 8. 8 bytes, no options. Okay.
Also here, TCP header, sir. Like this 60 bytes in the sense it is all calculating the source port.
Everything. Yes, everything calculated. Yes.
Even the push.
Push. Yeah, all these flags and everything, all calculated size. Okay. The sizes are calculated based on these things only. Okay. That's why we say 20 to 60 bytes. If we do not have the options, so it will be 20. If we have the options, it will be 60.
Windows size, it's
Window size is different.
size.
That is a different case. Window size is just that receiver is advertising that, okay, how much data I can receive. Okay.